Hello class, welcome to SciChem. Here we are another session for lecture 3 of chemical kinetics. Before watching the lecture 3, make sure you have watched previous lecture. So let's start. Let's start with the problem. For a particular reaction, value of rate constant is 3 into 10 to the power minus 3 liter square, mole inverse 2 and second inverse. Find out the order. So what is given here? What is given here? K have value 3 into 10 to the power minus 3 liter square, mole inverse 2 second minus 1 or second inverse. So we have already discussed the unit of rate constant, that K is equal to mole per liter power 1 minus n time inverse. By comparing both, I can write here. So sorry. Here asking in order of the reaction, that is n. So I can write here K is equal to 3 into 10 to the power minus 3 mole per liter power minus 2 second inverse. By comparing 2, this is equation 1. By comparing equation 1 and 2, I can write here 1 minus n is equal to minus 2, 1 plus 2 is equal to n, so n is equal to 3. So for this reaction I have order, n equal to 3 just. So what is order of reaction? Order may be defined as the sum of power of all concentration terms appearing in rate law expression is known as order of reaction. We have already discussed what is law of mass action and rate law equation. Law of mass action is a theoretical concept, whereas rate law expression is an experimental concept. So what is order? Order may be defined as the sum of power of all concentration terms appearing in rate law expression is known as order. So let us consider reaction A plus B plus C gives rise to product, which is a balanced chemical equation. So I can say that by experiment let R directly proportional to A raw power P, where P is order with respect to A, and similarly R directly proportional to B raw power Q, where Q is order with respect to B. Similarly, R directly proportional to 0 power R where R is order with respect to C. So these are experimental data. So by seeing this experimental data, I can write here rate of a reaction, sorry, there is some technical mistake. So let us consider reaction A plus B plus C gives rise to product. So I can rate the rate of reaction directly proportional to A to power P, B to power Q, C to power R, where P is order with respect to A concentration term, Q is order with respect to B concentration term, R is order with respect to C concentration term. So I can say that overall order of reaction is equal to N equal to P plus Q plus R. So this is the sum of power of all concentration term that are appearing in a rate law expression. What is rate law expression? This is rate law expression. So order may be defined as the sum of all concentration terms that are appear in the rate law expression. Then come to next part, that is a problem. Read carefully or take a screenshot. For a particular reaction 2A plus B for a particular reaction 2A plus B gives rise to product order with respect to A is 2 and order with respect to B is -1. So what is given here? I have a reaction 2A plus B gives rise to product and order of A is 2, B is -1. So here I am solving first question, that is A. Write rate law expression. So I can write here rate is equal to K into A to power 2 and B's power -1. This is the first answer. Similarly, for question number B, total order of reaction. Total order equal to N equal to 2 plus -1, that will be 1. So the total order is 1. Similarly, question number C, what will be the effect on rate if concentration of A is doubled? Read carefully. What will be the effect on rate if concentration of A is doubled? So I can write here rate is equal to K into A to power 2 B to power -1. So it is asking what will be the effect on rate if a concentration of A is doubled. The concentration of A, here I have to double the concentration of A. While doubling the concentration of A, you have to keep the concentration of B constant. Don't change concentration of B. He is just asking increase the concentration of A by double. So here I can write rate is equal to K into double means 2A square B to power -1. So K is equal to 4A square B to power -1. So I can say that rate increases by 4 times. How can I know that rate increases by 4 times? Just compare the rate here this rate and this rate. It is initial rate and it is final rate. Just compare initial and final before doubling the concentration and after doubling the concentration. I can assure that rate increases by 4 times. Similarly, question number D, here I am solving it. D, what will be the effect on rate if concentration of B is reduced to 1/3? So similarly I can write here rate is equal to K into A raw power 2 and B raw power minus 1. So rate is equal to K into A raw power 2 and B by 3 or minus 1. Remember one thing, while changing concentration of B, you have to put the concentration of A constant. So rate is equal to K into A raw power 2 and B raw power minus 1, 3 raw power minus 1 raw power minus 1. So the rate is equal to K into A raw power 2 B raw power minus 1 into 3. This is final rate and this is initial rate. Compare both. I can say that rate increases by 3 times. Okay. Then another question is there, what will be the effect on rate if volume of container is doubled? So again question answer E. What will be the effect on rate if volume of container is doubled? If volume of container is doubled, I can say that the concentration becomes half. As we have already discussed, volume, since concentration inversely proportional to volume, if volume is doubled then concentration becomes half. So here rate is equal to K into A raw power 2 B raw power minus 1. So I can write that K is equal to A by 2 raw power 2 B by 2 raw power minus 1. So here K A raw power 2 and B raw power minus 1, I can say that 1 by 4 into 2. So 2 2 is 4. So K into A raw power 2 B raw power minus 1 into 1 by 2. So this is the final rate and this is initial rate. By comparing these two, I can say that rate decreases by 2 times. So by this, just watch the approach to solve the problem. So we have already discussed the 5 types of problem regarding order of a reaction. Here another question, for the reaction A gives rise to product, rate becomes half when concentration of A increases by 4 times, then determine order with respect to A. Here I have a equation, A gives rise to product and rate becomes half when concentration of A increases by 4 times, then determine order with respect to A. This is the above which I have already done. This is the problem solving approach, but you don't need to worry about that. We have a shortcut. I have already told you, rate directly proportional to concentration power order, or change in a rate is equal to change in concentration power order. So here I can put here change in rate. What amount of rate changes for the reaction A gives rise to product? Rate becomes half. So I can say that 1 by 2. Change in rate is 1 by 2. If concentration of A increases by 4 times, 4, change in concentration is 4, then determine order with respect to A. So I can put here n. By solving this I can get 2 power minus 1 is equal to 2 to the power 2n. So comparing 2n equal to minus 1 or n is equal to minus 1 by 2. This is the order with respect to A. So this type of small problem you can easily solve. So let us come to next part. Important example illustrating different value of order and rate law equation. So this is the first reaction. 2N2O5 gives rise to 4NO2 plus O2. Just look at the reaction. Here rate is equal to K into N2O5 power minus 1. N2O5 power 1. Similarly, consider next reaction. 5Br minus BrO3 minus 6H plus 3Br2 plus 3H2O. Rate is equal to K into 5Br power minus 1 BrO3 minus 1 H plus 1. Sorry, this is not should be present here. This is only Br. Mistakenly I have put there. Sorry, this is only Br. Similarly, see reaction 3 and reaction 4. What you have seen there that 2N2O5, in the first case the stoichiometry is 2, but in case of order is 1. Here the stoichiometry is 5 plus 1, 6 plus 6 will be 12, but here the order is minus 1, it is 1. Similarly, reaction 3, 2O3 gives rise to 3O2, R is equal to K into O3 to the power 2 and O2 power minus 1. This is the peculiar reaction because here the rate law equation involves product O2 to the power minus 1 and it is possible. Similarly, reaction 4, 2SO2 plus O2 gives rise to 2SO3. We have NO as catalyst, R is equal to K into O2 to the power 2 and NO power 1. NO is the catalyst. So here in rate law equation we have NO catalyst. So by seeing the above 4 equation, I can easily say that from all the above reaction, it is clear that there is no relationship between stoichiometry of reaction and order of reaction. By simply seeing the reaction, we cannot write order of the reaction, as order can be determined only and only experimentally. Next is order is always determined experimentally, which is fixed, but stoichiometry of the reaction is on our hand. We can change the stoichiometry. Simply 2N2O5 gives rise to 4NO2 plus O2. Here I can write 4N2O5 gives rise to 8NO2 plus O2. Simple. Stoichiometry I can change, but order could not be changed. Similarly, rate law expression normally involves reactant, but it may involve product. It is important, product and catalyst, but reaction intermediates are not involved in rate law expression. So normally in rate law expression, this is the rate law expression, this is rate law expression. In this rate law expression, normally reactants are involved, but in case number 3, here products are involved. In case number 4, here the catalysts are also involved, but there are no rate law expression that involves reaction intermediates, just like your carbocations and carboanions. On changing stoichiometry, the rate of reaction and rate constant changes, but order does not. How? Consider here in this reaction. First, two N2O5 gives rise to 4NO2 plus O2. Here I can write rate is equal to 1 by 2 of minus dN2O5 by dt. By changing the stoichiometry, 4N2O5 gives rise to 8NO2 plus 2O2. Here I can write R is equal to 1 by 4 minus dN2O5 by dt. By seeing the above this case and this case, I can say that on changing stoichiometry of the reaction, the rate of reaction, rate constant changes, but order does not changes. Any reaction, simple or not, cannot be decided by looking stoichiometry of the reaction. Any reaction which is simple or not cannot be decided by simply seeing the reaction. It should be decided experimentally with the help of mechanism of the reaction. Any reaction would be simple or not. We cannot decide by merely seeing the reaction. It have to be determined experimentally. So let us consider a reaction as follows. H2 plus Cl2 gives rise to 2HCl. So here R is equal to K into H to the power 0 Cl to the power 0. Here rate does not depend upon molar concentration of hydrogen and chlorine. So this is not a simple reaction. Similarly, H2 plus Br2 gives rise to 2HBr, and H2 plus I2 gives rise to 2HI. I can write here R is equal to H to power 1 and I to power 1. This is a simple reaction. But in case of hydrogen and chlorine, rate is independent of a molar concentration of hydrogen and molar concentration of chlorine. This is not a simple reaction. And similarly for hydrogen and bromine, H2 plus Br2 gives rise to 2HBr. Here I can write rate is equal to K into H to the power 1 Br to the power 1 by 2 divided by 1 plus K2 HBr divided by Br2. So this is not a simple reaction. So by seeing simply the reaction, we cannot decide whether the reaction is simple or complex. So we have to do some experiment. So this is all about important features of order of reaction. Hope you get clear. Thank you.